reason. I work at IMVU.com, IMVU.com if you prefer. We've been ramping up the use of Haskell as a backend server application language for about 2 years now. And it basically started with me monkeying around with programming languages, because this is one of the things that I do. I was playing with a web framework called Yesod. I hope I'm pronouncing that correctly. And I got to the part of the documentation where they talk about how, in principle, URLs in Yesod web applications are type safe, which means that if you were to delete a web page from an application, and for that web page still to be linked from somewhere, then the compile would break. Now, other language ecosystems don't think about that problem. This is just a thing that kind of happens, and you set up stuff like production monitoring, and you set up unit tests, and you cross your fingers real hard that when it actually does happen in production, that you're going to find out about it and fix it real fast, because you've kind of given up on the idea that you're going to completely prevent this problem from happening. You just kind of it's just this implicit surrender that, you know what, you're just not going to be able to encode this invariant in your application. And that really got me thinking, not just about URLs, but just more generally the kinds of the kinds of places where we give up in our applications and just say, well, you know what, this is going to be enforced at runtime, and we're going to try real hard to catch it quickly. We're going to catch it in our unit tests, and so on and so forth. So that got me thinking about how to actually go ahead and pitch a new programming language, a niche programming language, forgive me for saying, at an organization that already has 8 years of PHP experience and 80 engineers. And I don't even remember the number, about 160,000 concurrent customers a day. Like, how do you actually go about doing it? So the approach I went was the least risky way possible, which was basically I went to technical leadership and said, I'm going to drop in a bit-for-bit copy of this one high-traffic, low-priority web service, and we're going to flip a switch in the load balancer, and if anything goes wrong, we can switch back to the old implementation instantaneously, and we'll see how it goes. And the operations person that I was working with accidentally made a mistake, and instead of flipping it back to 10%, he flipped it back to 100%. And the two low-end machines that we had set up, the two machines that were set aside, and they were going to retire them, they handled the load just fine. It didn't show up on any of the graphs. So, so that was good. The next step was basically to leave it there for 3 months with no manual intervention whatsoever. And many software stacks can claim this level of reliability. This is not, earth-shattering, but it definitely means that the Haskell ecosystem is ready. It is production hardened. It is, it has the kind of quality where you can throw 100,000 requests per second at it, and 100,000. Not quite 100,000, but anyway, you can throw a lot of load at it for a very long time, and the system is not just going to fall over. It's not going to require a lot of manual care and feeding. And when you're dealing with a big, long-lived system like this, you really want to be able to build a feature, ship it, and then move your engineers onto something else, move on to new features, and just leave the feature and let it go. And this was an unqualified success. This was fine. We had no problem whatsoever with this. So the next step was a little bit harrowing, and in retrospect, it was quite a lot of fun. We made a deal with engineering management, because engineering management had a lot of very rational concerns that needed to be dealt with that were not technical in nature. Stuff like, how do you hire people? Or if you run into some obscure bug in some corner of some third-party dependency that you've pulled in, can you diagnose it? Can you find a person to help you diagnose it? This kind of, and these are not technical problems. These are people problems. So we wanted to test this, and the deal we made was that there was a new important project that we were going to ship to customers, and we were going to do it in Haskell. I and one other colleague were going to spin up 3 engineers. We were going to teach them Haskell on the job. And we had a deadline that we were going to hit no matter what. That meant, for instance, if we were 2/3 of the way in and it looked like we weren't going to get it, that meant Haskell was done, we did everything all over, and the deadline stands. So it was, no matter what, do it. And we did, in fact, lose quite a few nights catching up, because it turns out that when you've built an application in one language over 8 years, you build up quite a lot of infrastructure that's very, very nice. We have a push systems, for instance, where when you push PHP code out, it sends it to a couple of machines, and if those machines freak out, then it automatically rolls it back and rejects your code. So we had to catch up all this stuff. That was actually the only thing that really went wrong, was that we didn't estimate that stuff. So the Haskell literate people who started, I and my friend Imran, we built all of the infrastructure stuff, and the new guys wrote all of the application level code. So the spin up wasn't actually that bad. And you know, the biggest stumbling blocks we ran into were things like Haskell has so many different ways to deal with error handling. You can capture things in either, you can use exceptions, and you know, we even played with a library that used type classes to affect checked exceptions from Java. So things like that. But it works fine. It runs on way less physical hardware than we use. We developed PHP, and it's still running today, in fact. So today, we've been doing this for quite some time. We have one engineer who continues to work in that particular application, and he's building new features, extending it, exploring new business opportunities. And so now I can finally say, this is what it's like to be doing Haskell in a reasonably large code base that is reasonably old, that is also production sensitive, and has a lot of people who have invested their time in it, some of whom do not remember how the code works anymore. And this is a serious problem. If I really feel for the Facebook guys, and I really understand why they invented Hack, because they have more PHP code than anybody, and it's super old. And none of the people who wrote any given piece of code can be expected to remember how it works. And there are all of these invariants and conditions that must be met with all of this data that has no, there's no static verification of the structure of any of this data. And so, you give someone a task to say, well, we want you to clip this parameter from this function. And they've got 10 million lines of PHP. Good luck. Good luck. So here we are, and one thing I can offer very definitively is that once you have an application, and that application has an opinion about how you should be writing code, it has an opinion about how you should be handling errors, about how you should be naming stuff, about when you should use monadic style versus pure functions and all this other stuff, Haskell becomes way, way easier to train people up on. You just say, this is the way you do it. There are other ways to do it, but we're not doing it here. And you can just paper over that, and you can just move on. And people can kind of pick up the operational, how to get stuff done in the language much easier. We can spin up a new engineer on Haskell, and it takes about the same amount of effort that it takes to spin them up on our particular brand of PHP. It's not that much different. Whenever we have a problem that requires concurrency, Haskell is like nothing else I know. It's like C++ except safe, or Go except safe, or Erlang except with types, i.e. safe. It's just magnificent. You can create threads and throw stuff back and forth, and the overhead is very low, and the expression is very clear, and you just go. Haskell is the only language that we look to whenever we have some kind of HTTP process that has to manage stuff in RAM, like between requests. PHP has no answer to that, and there's no reasonable way to do it, so we just do it in Haskell, and it's much easier to just throw some crap in an mvar or something like that. It works great. The last thing, which I think is probably the thing that I'm personally the most excited about, is how test-driven development works with Haskell. I've been pushing test-driven development at IMVU.com for quite a long time. I put a lot of my effort into making sure that the testable platform that goes into every language that we use, and it's about 7 languages now, tends towards writing in RAM tests that are actually reliable and that can be spun off on multiple cores and don't have to be diagnosed, because when you have a test that's intermittent, that is a constant factor on your overhead. We have 7 machine hours of PHP tests, and they run on every single commit. And if they were 99% reliable, then we would have a team of people working on those all the time. We don't, because we put in the elbow grease to get 99.99%, and that's what it takes. On the Haskell side, we took advantage of the opportunity to use a little bit of type class mumbo jumbo to set up our tests such that in tests you are running on top of the state monad, and in production you're running on top of a transformer stack that lives on top of I/O, which means that the code looks like it's just doing stuff, and there is no test overhead except for the type signatures. But the tests are 100% deterministic. There is no opportunity for non-deterministic code to get in there, short of stuff like lift.io, because the build will break. These tests never fail, or they always fail. And that's fine too. That's not possible in anything else that I know. And as someone who is very excited about long-lived applications that have to be written and then withstand sustained maintenance for 8 years, 9 years across a team of 80 people, that is, it is an incomparable step function. You can't get that anywhere else, and it's just really great. Because, well, so the last point I'll offer is refactoring doesn't pay the bills, products do, and I want to spend as little time refactoring as possible. And okay, so I worded that really terribly. I apologize for that. But the other last thing is that refactoring Haskell in arbitrarily large code bases does not get more difficult. There's more elbow grease that goes into it if you have to change a function that's applied 6,000 times in your 3 million line code base. But it's not harder. You just have to go to the next thing and do the thing, or go to the next thing, or finally give up and write a programmatic syntax transformer or something like that. These things are just absolutely incredible, and there's nothing like it in anything else that also has industrial grade performance, industrial grade reliability. Thank you very much.
Okay, and next we have Jeff from AlphaCloud.